Chapter 7 pre-quiz part 1. Here's the key. So we're finding cosine of beta. So one way to do it is put this as x and this is r, and then you could use Pythagorean theorem to find your y, because sine is just y over r. So that's one way you can do it. Here we want to use probably our identities, because that's what we're going to use throughout the rest of this chapter. So cosine and sine is sine squared plus cosine squared equals 1. So then I can change that to cosine squared of our angle, which is beta. I shouldn't have put that in there. Beta. Cosine squared of beta equals, cosine 1 minus cosine squared of beta equals sine squared of beta. 1 minus, so we just manipulate that formula. We square root both sides, so we get sine of beta equals plus or minus. We have to put the plus or minus in front because we don't know what quadrant. Cosine of squared of beta. Well, so that means sine of beta will equal, we know what cosine is, so we can plug that in, plus or minus the square root of 1 minus 5/8 squared. So that's plus or minus the square root of 1 minus 25, 64, which equals plus or minus square root of 64 over 64. Minus 25 over 64, which I believe is 39, yeah, which equals plus or minus the square root of 39 over 39 over 64, which equals plus or minus the square root of 39 over the square root of 64, which equals plus or minus square root of 39 over 8. So sine of beta is equal to plus or minus the square root of 39 over 8. There you go, all done. Okay, finding tangent, or you're given tangent, you want to find sine and cosine. So here, we don't want to assume that our radius is 1, because if you do that, then you can say, okay, well, tangent of beta is equal to sine over cosine. So that means sine is -5 and cosine is 3, right? But we can't do that, because if we do that, that means that our r would be 1, and it says our radius is not 1. But we will use this, we can use this later on once we have cosine or sine. So the other relationship is there's no direct relationship between tangent and sine, or sine and cosine, but we know that cosine of beta is 1 over secant of beta. And we have this relationship between tangent squared of beta plus 1 and secant, right, of beta. Because then we can just go flip this secant when we're done. We have it. So we're going to use that kind of same Pythagorean identity. A different one with tangent secant. So we're going to go ahead and square tangent. So that's squaring to -5/3. And again, we don't know what quadrant, so we're going to put a plus and minus in front of sine and cosine for our answers. So we're going to square this, and then we're going to add 1, and that's going to give us secant, and then we can go ahead and flip that, and we'll have our answer. So that's 9 over 9, 25 over 9, so that is 34. So that equals 34 over 9, and then we're going to have the square root, because we have secant equals secant squared of beta, so we'll go ahead and square root both sides. So that's square root of the top and square root of the bottom, so we get secant, which cosine is what we need, so our secant is square root of 39 over 3. So then we can go ahead and flip that, so that's 3 over 39, or not 39, 34. I was thinking from the previous answer, right? Sorry, that's 34. So 34, so we flip that, and we get cosine is equal to 3 over root 34. So there's cosine of beta, and we can rationalize it. So cosine of beta is equal to 3 root 34 over 34. And then we can go ahead and use this tangent thing to find our sine, right? Because I know tangent is negative root 5, or sorry, negative 5 over 3. And we know cosine is 3 root 34 over 34. So then we can multiply both sides. When we're dividing by 3 root 34 over 34, we can multiply it on both sides, and that would get rid of it out of its denominator. Probably need some more room here. So times by 3 square root 34 over 34 times by 3 square root 34 over 34. And so the 3's will cancel. And so we'll get, and we know it's going to be plus or minus because this one was plus or minus, right? And so this one will be plus or minus negative 5. So we can just put 5 because we know it's going to be plus or minus square root 34 over 34. So those are our answers. Write this up. We could also went from cosine, just like example number 1. We could use that Pythagorean identity to find sine. So that's another way that you can do it. Okay, so I messed up. This shouldn't be cosine here. This should be sine of A and not cosine of A. So if you want to do that correction, that's fine, because this will be a lot simpler if you switch that and make that correction there. Okay, so we're really taking cotangent of A and timesing that by sine of A. So we can rewrite cotangent as cosine of A over sine of A. And now we're timesing that by sine of A. So you can see how easy it is. We just cancel those, right? So we get cosine of A, and that one's done, right? If you don't make that correction, then it becomes like cosecant of A minus sine of A. And that's really not simplified, so. Okay, so then here we go, verifying, right? We're using those identities in order to verify that cotangent of x times sine of x equals cosine of x, or divided by cosine of x equals 1. So we want to use our Pythagorean identities and just rewrite one side, right? So we want to rewrite one side. One step that you can do is turn everything into sine and cosine. So we might want to take cotangent here and turn that into cosine of x over sine of x. Right, so that kind of looks like the same example, and you can see in the numerator it is the same as our example from the last one that I just corrected, right? Because now these signs will cancel out, and then on bottom we have cosine of x, and so we get cosine of x once the signs cancel out over cosine of x, which indeed equals 1. So left hand side does equal the right hand side. We showed our work in order to do that. There it is, it's done. There's our work shown. We're done. Okay, here's another one. We're verifying. Remember, verifying is not solving. I'm not solving. I can't multiply by sine squared on both sides. Can't do that. I just need to take one side and turn it to the other. All right. You can work both sides, but you got to work one at a time. So for instance, if I want to work both sides, I might say, hey, I know what secant is. Secant is 1 plus, or I'll do it right under it, 1 plus tangent squared, right, of x. And then I know what tangent is. Okay, that's sine squared over cosine squared. All right. So then I'm going to go, okay, now I don't know what to do, right? Now I don't know what to do, so I'll just divide this each side. So now I don't know what to do anymore. So now I go to the other side and start reworking that, right? Well, I know 1 minus secant squared, that's tangent squared, right? So that's tangent squared. So now look, I have a tangent and tangent, so maybe I shouldn't have gone this far of sine over cosine, right? But we'll find out. So now I can do this. Well, since I rewrote tangent as sine over cosine, why don't I rewrite that tangent as sine over cosine? So sine of x squared, right? And over cosine squared x over this sine on bottom. Okay, and now when I'm multiplying by sine, or when I'm dividing by sine, I'm multiplying by 1 over sine. Or yeah, 1 divided by sine. So we get sine squared x over cosine squared x, and then times by 1 over sine squared x. So that is, these would cancel out, and so I'd get 1 over cosine squared x. And then I know 1 over cosine squared x is secant squared x, right? So, oh, look, that was at my beginning, right? Secant squared x, that's what I was trying to get to. So actually, I don't even need to do this, right? So that's why it says in the very first, work with the more complicated side, right? So we want to work always with the more complicated side. So that's what we did here, work more with the complicated side. But I was just showing you that you can work both sides. You just do one at a time. So left-hand side does equal right-hand side. And so on a test or a quiz, I'll follow your work to make sure you did the identities correctly, okay? And you did your algebra and stuff correctly as well. So this one, you are gonna work both sides, right? They're pretty complicated on both sides, so you can do anything. This one on the right, this top one, actually looks like 1 minus 2 times something plus that same something squared, right? So isn't that just a quadratic? X squared minus 2x plus 1. My x just represents cosine. That's what's being squared here, right? Is the cosine, and that's what's being times by negative 2 is the cosine. So really, this is just a quadratic. X minus 1 times x minus 1, right? That would get me that. So my x is just representing cosine, so I can take this one on the right and rewrite it as cosine of alpha minus 1 times cosine of alpha minus 1. Okay, and then on bottom we could rewrite that negative out there. That's okay. So if we just think of that sine squared alpha as just without the negative, we know that is 1 minus cosine squared of alpha. But since that negative in there, we would just multiply this by negative, so that would turn that to a -1 and that to a positive cosine squared alpha. Okay, so that's all I can see as I can do. Maybe I don't need to go that far, right? So let's go jump over to the other side. And here we want to take cotangent and cosecant, maybe write it in terms of sine and cosine. So if we write it in terms of sine and cosine, cotangent would be cosine of alpha over sine of alpha, and cosecant would be 1 over sine of alpha. And then on bottom we would have the same thing except for it's a positive, right? And now we can do some algebra here once we make our conversions. You always try to do some algebra when you can. So here I have fractions. I can combine those fractions. So we have cosine of alpha minus 1 over sine of alpha on top. And then on bottom I have the same thing except for a plus. So cosine of alpha plus 1 over sine of alpha. Now when I'm dividing by a fraction, I'm multiplying by its reciprocal, right? So cosine of alpha minus 1 over sine of alpha, and now I'm going to multiply that by the reciprocal of the denominator, right? Okay, so that means these are going to cancel out. Ooh, I tried to switch colors there. Those are going to cancel out, right? So then we get cosine of alpha minus 1 over cosine of alpha plus 1. So the very last hint on that list of hints of 7 or whatever in section 2, it says when you have a cosine of alpha plus 1 or a sine or a 1 plus sine, right, that you multiply by the conjugate. Well, the same thing's true with a cosine. So if you have cosine plus 1 or 1 plus cosine or 1 minus cosine on bottom and the denominator, you want to multiply by the conjugates, because when you multiply by the conjugates, the middle is going to drop out, but you just need to multiply top and bottom, right? Because that doesn't change my fraction. Okay, it's just like 2/3 is the same as 4/6, right? Top and bottom by 2. All right, so we multiply here on bottom. We have conjugates, so that's going to be cosine squared minus 1, or cosine of alpha. So cosine squared of alpha minus 1 on bottom, and then on top we're going to get, well, on top, let's just keep this separate, minus 1. Because if we look at where we're going, right, that's what you always want to do, kind of look where you're going. I look where I'm going over here and I can see, hey, that's what I need on top. I need a cosine of alpha minus 1, 2 of them, right? And that's what I got, 2 of them. And then on bottom, I need a cosine squared alpha minus 1, and I have a cosine squared, right? It's a positive cosine squared and it's a minus 1. So yep, so I'm done. Left-hand side does equal right-hand side. So here on number 7, we're finding the exact values. That means don't use your calculator. So here we want to use probably the sum and difference formulas because we don't have cosine of 75 on our fingers, right? We have 0, we have 30, we have 45, we have 60, and we have 90, right? And then they're, you know, the same thing, 135, 120, 150, those things as well that we can find. So cosine of negative 75, how can we rewrite that as something that we know, right? So we know minus 75, that could be a negative 30 and a negative 45. We could do 45 or we could do a 45 minus 120, right? Because that would be, yeah, that'd be 75. All right, because 45 plus 75, 5 is 80 for 120. There we go. So we can do this. Okay, so Cosette is arranged in the date. So she hangs out with her sister. Oh, and that's a 120 there, and then the signs change, right? So it's a plus, and then cosine, and then Cosette makes Sinbad hang out with his brother. Remember, Cosette always comes first, so we can find cosine of 45, which is root 2 over 2. And so is sine of 45, and then cosine and sine of 120. So we're looking at 120, so that's off of 60 degrees. So cosine of a 60 is is actually 1/2, right? And so since we're in the second quadrant, 120 is in the second quadrant, it's a negative 1/2. So we're not subtracting here, we're still multiplying, but it's just a negative 1/2. Here we're still multiplying, but it's just it's going to actually be positive root 3 over 2. So then we can go ahead and multiply these, so we get negative root 2, so negative's on the outside of that square root, over 4 plus root 6, because they're both square roots, so we can multiply two different square roots over 4. Now we can add, but we can't add those or subtract those on top because they're different numbers underneath the square roots, right? So adding, you can't add numbers underneath. Multiplying, you can multiply numbers underneath roots. So that's a negative root 2 plus root 6 all over 4. So there's our answer for that. Negative sine of 15, so how about 30 minus 45? Right, so sine, this is the same as sine of 30 minus 45. Remember, you can do tons of different ones here, but that's how 30 minus 45 is a negative 15. So here we go, we can go, how does Sinbad arrange the date? Well, he takes himself and he hangs out with Cosette. He thinks their signs are the same, and then he takes his brother. So that's how I had to switch angles here. So instead of a 30, I'm going to write a 45 because I need his brother. He puts him with his sister. Okay, so then I find what is the coordinates of 30 degrees and 45 degrees, right? Well, 30 degrees for sine is 1/2. That makes cosine root 3 over 2. And then cosine and sine for 45 are both the same, root 2 over 2. Again, we're multiplying here. We keep the signs the same. And then root 2 over 2 as well. And again, we're multiplying. So then we get root 2 over 4 minus root 6 over 4. You notice a lot of these answers will have the same kind of numbers in them, right? Because as we go around the unit circle, all these, we get root 3 over 2, 1/2 root 2 over 2, right? We get the same answers for all of them. So that's why a lot of these will look the same, except for sometimes there'll be subtraction in the middle, sometimes it'll be positive, sometimes your negative will be on the root 2 instead of that one. So you get that kind of thing. All right, so there's your answer for that. Here we go tangent, right? So tangent 1, well, we could do this, right? We're probably going to add, but it's probably going to be like a 4 and a 9. 4 and a 9 will work, right? So 4 pi over 12 plus 9 pi over 12 would equal 13 pi over 12. So I'm doing the radians real quick, but I'll switch this to degrees is probably the way that you want to do it, right? So you could switch this to degrees by multiplying by 180 over pi, because then your pi's will cancel. And then your 12 would be divided by 180 is 15, and then 15 times 3, I don't know, I'm going to use a calculator for that. But this one over here, we can simplify to pi over 3, and this one simplifies to 3 pi over 4, right? Correct, right? Divided by 3 is 3, divided by 3 is 4. So there, as we can see, I'm actually going to probably do a 60-degree angle and a 135-degree angle. So that means that 13 times 15 is actually 195. And you can type that on a calculator. 13 times 15 equals 195. Hey! So we're finding tangent of 195, which is going to be a 60 degree plus a 35 degree. Right? So you could do radians, or you can do so just switch to degrees. But eventually you'll have the same dealing with the 60 degree plus a 135 degree. So 135 degree again is pi 4, so that's what's nice about the radians. I know it's a fourth, so I know I'm going to look at 45, right, which is going to be, now tangent's a little bit different, right? Tangent doesn't have a little formula for it, but it is, tangent is tan of the first, keep the sign the same on top, tan of the second degree, or measure, angle, and then 1, switch the sign, minus tan of the first times tan of the second. And what sucks about tangent is that, stinks about tangent is probably going to have to rationalize your denominator. So we'll put this over here. So tan of 60 is divided by 3, right, for radians, so that means it's just a root 3. And then 135 is just a negative answer, right, because we're in the second quadrant, and tan is negative in the second quadrant, but it's a 45 degree, so that's just 1, so it's a negative 1. And then on bottom, so you could really write that as square root 3 minus 1 is fine. Okay, and then on bottom we have a 1 minus tan of 60, which is root 3, and then times by 135, which is a negative 1. I'll go ahead and put this back for those people that are just reading it. And that equals, so I'll simplify, minus 1 over 1 plus, because it's a negative times a negative, right, plus root 3. Okay, so then here I'm going to have to rationalize, right? So we're going to have to rationalize this, which that's the only thing that stinks about tangent, because if you didn't have to, then it would be pretty quick. So we got to multiply by the conjugate of the denominator, right? We got to FOIL the top, but on bottom we have conjugates, so that's great. So we get 1 minus 3, which is a negative 2. But on top we get a square root 3, and then a 3, a negative 3, and then a negative 1, and then square root 3 times 1 is square root 3. That's the negative 3, and then 1 times that, and we get a positive root 3. So we get 2 roots of 3, and then a minus 4. And then we can take out a 2 from the top. And then we can cancel out those 2's. So then we just get a negative square root 3 minus 2, and we can distribute that negative, so that's a negative square root 3 plus 2. So there's our final answer. So that's the only thing that sucks about tangent, rationalizing that denominator. Okay, so we have cotangent of A, 7 over 24, and cosecant of B is negative 5 over 3. Quadrant A is in quadrant 3 and B is in quadrant 4, and we want to find sine of A minus B. So that means in order to find sine of A minus B, well, that is sine of A times cosine of B minus sine of B times cosine of A, right? So then we need to find a sine of A and a cosine of B, right? Well, we have cotangent. Ooh, so cotangent. So we well, let's start with the cosecant of B. So if we take the cosecant of B and we flip that, that means we have sine of B. So we know sine of B is equal to negative 3/5. Okay, and if we have the sine of B, that means we can find cosine of B by taking 1 minus sine squared of B and square rooting it, right? And we know we're in B is in the 4th quadrant, so we know B is in the 4th quadrant, so cosine is going to be positive, so this is going to be positive. And so then we square that, we get 9 over 25, and subtract 1, which is 25 over 25. So that's going to be 16 over 25, and then we're going to square root that. And so we get positive because we know it's going to be positive. We got 4 over 5. So we know it's going to be 4 over 5. So cosine of B is 4 over 5. And we know it's going to be positive. Okay, so, but now we need to find A, right? We need to find sine of A and sine and cosine of A. Okay, so, and we're given cotangent. Well, that stinks. But we have some identities that we can use to go from cotangent of A to cosecant. So we have 1 plus cotangent squared of A, so that means we have to square this, so that's 49 over whatever 24 squared is. 576. So we got to take 576 over 576, and we have to add 49 to that. And we get 625. Hey, that's a perfect square over 576. Oops, 76. You square root that. Equals cosecant squared of x. So that's why we have to square root that. Secant of x. Square root that. So we get 25 over 24. So that is cosecant of, not x, sorry, of b, right? Because this is of, oh no, it's of a. So that's of a. So that's of a. So that's of a. A, and this is cosecant of A, so that means sine of A would be 24 over 25. Okay, so now we have sine of A. So now we have sine of A is 24 over 25. And then we can find cosine. You can find cosine of A by squaring that, which gets us back to 625 over 576. And then we got to take 1 minus that, which is 525. 1 minus that, which is cosine squared. Cosine of A. So that is 576. 570, actually, real quick. This would be flipped, right? It's 24 over 25.
The biggest benefit.
Oops. So that is 576 over 625, right? Because it's 24 over 25. So that means that it is 625 over 625. Which we've kind of already did the math here, is 79 over 625. Right? So that is 49 over 625. So that's just going to be 7 over, so cosine, I guess we can do it down here. Whew. Oops. Cosine of A equals 7 over 25. And what is quadrant A in? What is angle A in? Is in quadrant 3. So cosine is negative. And sine is also negative because we're in quadrant 3. Okay, so let's come back up here. This is negative, and this is 7 over 25. And we could have probably actually solved that a lot easier because cosine or cotangent is x over y, right? So once we figured out that we have 25 on bottom, we could have used that a lot easier of doing it. Okay, so let's go ahead and cross this one out. We'll come do that one in a little bit, and we'll cross this one out too because we need to make room. Okay, so now we're finding sine of A minus B. So sine of A minus B is sine of A cosine of A or B minus sine of B times cosine of A. Well, now we have these answers, right? Cosine of A is negative 7/25. Sine of B is negative what do we say, 24 25ths. And we're subtracting that, and then sorry, sine of A goes over here on this side, so this is negative 24 25ths. Cosine of B and sine of B is negative 3/5, negative 3/5, and cosine of B is 4/5, positive 4/5. Okay, so we can multiply 4 times 24. That's 96, right? So 96, negative 96 over 5 times 25 is 125. Minus, because of the negative times a negative times a negative is going to be a negative, 21 over 125. So we can add this together. So those are both negative, so we're going to add them. So negative 97 plus 20 is 117 over 125. So the answer is negative 117 over 125. Okay, so now we want to find cosine of 2a from number 10. And so cosine of 2a is 2 cosine squared a minus 1. So we can use that formula because we know cosine of a is negative 7 over 25, right, from our previous problem. Negative 7 over 25. And so we use our double angle formula. So we get negative 14 over 25, and we're going to subtract 1, which is 25 over 25, which is negative 39 over 25. And so there's cosine of our double angle of A. Okay, you could also do the other two formulas too as well, but that's cosine of the double angle. So that one's done. Now we can look at our next one. Okay, so here's another one, double angle cosine of beta this time. So that's 2 times cosine squared of beta. Ooh, did I double that? Maybe I didn't double that from before. I did not double that. Sorry, go back real quick. We got to double this, right? Double that 7, so that's 49. So that's 49 over 625. And we got to times that by 2 and then subtract 1. So then we can erase this here. So that's 49 times 2 is 98. So 98 over 625. Subtract 1, which is 625 over 625. And so 625 minus 98. Right, so that's a negative 527 over 625. So there's actually the double angle, sorry, of A. Is that one. Okay, so now we can back to this one. So now we can make sure that, hey, we are going to subtract 1 at the end. So subtract 1 at the end, we're going to double this. So make sure you double it. 1 over 9, times it by 2, subtract 1, so times this by 2, we get 2 over 9. Subtract 1, subtract 1. So that's 2 over 9 minus 9 over 9. So that's 7 over 9, 7 over, negative 7 over 9. And there's our answer for cosine of 2 beta. Okay, so last one here. We're finding the exact value of sine over pi 8ths, so you can convert that to a degree if you want. And so to a degree if you want. And I give you a hint, use a half angle. Whenever you have pi 8, some form of 8ths, you're going to use a half angle 22.5, which is the same as pi 8ths. That you're going to use a half angle, and then like 67.5. Anytime you see a 0.5, you would use a half angle. Okay. So that means we basically, times this by 2. So sine of 22.5, we can use the half angle formula because 45 over 22 or over 2, sorry, is is 22.2, right? So if we take 22.5, sorry, and times by 2, we get 45. So our half angle formula for sine, plus and minus, right, is 1 minus cosine of our angle that's on top, which is 45, over 2. All right? So we can use this. So then cosine of 45 is root 2 over 2. And then we got to take 1 minus that. So 1 minus that. And then all over 2, and then square root. And then we have 2 over 2 minus root 2 over 2, all over 2, square rooted, plus or minus. Then we get a 2 minus root 2 over 2, all over 2, rooted, which is 2 minus root 2 all over 2 times by 1/2. The 2's can't cancel, right? So we get 2 minus root 2 all over 4. And we square root that. This is square rooted still. So then we get the square root of 2 minus root 2 over the square root of 4, which is 2. And then it's a plus and minus. Plus and minus. So that is done. You could have did the pi 8's fine too. And then you'd have by fourths, right? So you could do pi 8's times that by 2. So that would equal pi fourths. So that's what would go on top. So sine of pi fourths over 2. So that would be sine of pi 8 will equal square root plus or minus 1 minus cosine of pi fourths, because that's what's on top, right? So what's on top goes right here. What's on top goes right here. Okay, and then all over 2. And then it would be the same process, right? Equals this, boom, all the way down, the same. Okay, so that means sine of pi 8. So sine of pi 8 equals plus or minus the square root of 2 minus the square root of 2. So that's all inside the root there, over 2, divided by 2. There.